If you've ever used a graphics program that includes some mechanism for manipulating curves, you've probably run across Béziers. The usual presentation in such a program is that you lay down some points, and as you do, some nice curve is generated. Now, sometimes you may end up laying down the endpoints first and then have a manipulator for the tangency at the end, but that's just an issue of presentation in the program. The underlying form is that there's something called a control polygon, which are these line segments connected by these points, and the points are called control vertices. You manipulate the control vertices somehow, maybe indirectly, and the curve changes shape. So we're going to learn how to do that, how to compute those things. And to do that, we're going to use something called Casteljau's algorithm. Casteljau's algorithm is really a generalization of simple line interpolation. So let's start with a review of line interpolation. Here's a line. It's got two endpoints, and somehow we need to compute the points in between. So let's show those points. There's the red one, the red dot there indicates the position along the curve of interest. And as we increase some parameter, I always call it t, as we increase t along this curve, it moves from one endpoint to the other. And this is the formula that we're using when we do this. It says that the point, the red point, is equal to some weight times the first point plus some weight times the second point. I've arranged things so that the sum of these weights is 1. This equation is called the barycenter of those 2 points. So now, let's track t as we move it from one side to the other. So at one end, the weight on P0 is 1, and the weight on P1 is 0, so the influence is completely from P0. And as we increase our t, we have less P0 and more P1. If you're not familiar with this barycenter form where you weight points, you can have more points as you weight them, there's another form that's maybe a little easier to understand. We can do this coordinate-wise. So the x value of P of the point, the red point, is 1 minus t times the x value of the P0 point plus t times the x value of the P1 point. And we can do that for y, and we can do that for z. So now that we know how to create, how to interpolate points, we're going to start looking at the generalization for Béziers. We'll start with the control polygon for the Bézier. We can go ahead and compute, interpolate each of these segments of this polygon at our parameter t. So I've set my t to 0.2, and this is 0.2 on each of those segments. Now, that also forms a polygon. We can connect those points with a line segment. It makes a new polygon. We can evaluate 0.2 on each of those line segments. And that gives yet another polygon. In this case, the polygon has one segment. And we can do it again for that polygon. There's no more segments to compute, so that's our point on our Bézier. As we move t from one side to the other, that red dot traces out a path. And guess what? That path is exactly on our curve. And that's all there is to the Casteljau algorithm. Happy programming.